The third type of mesoscale circulation we're going to talk about are loop currents and the eddies they can form. When a current emerges into a more open area of the ocean, it can begin meandering. And just like we saw with the boundary currents, a meandering flow can pinch off an eddy. So here we have a fast flow entering a wider, more quiescent flow. It starts to meander and then it pinches off an eddy, and then that eddy is able to propagate away. So a really good example of a loop current is the Gulf of Mexico. So you've seen this figure before. It's the standard deviation of satellite altimetry, and where there are bright colors, you have a lot of variation in the sea surface, which is a result of mesoscale circulation. So over here we have the Gulf of Mexico, and you can see that there's a bright red spot in there indicating high eddy activity. So the loop current in the Gulf of Mexico is associated with the current that will become the Gulf Stream. Here we have that the lighter colors, the whites, are higher velocity than the blues, which are more quiescent water. And we have this ribbon of white here that comes through past the Yucatan Peninsula, through the Straits of Florida, along the east coast of the US up to Cape Hatteras. And you can see the eddies here associated with the meandering Gulf Stream that we talked about in a previous video. So you can see that this current going into the Gulf of Mexico meanders and sometimes pinches off an eddy, and we'll see later that these eddies can propagate to the west. So these two images are from a numerical model. The colors are the speed. So the bright reds are 120 centimeters a second, so just over a meter a second. And the blues are low velocity regions. Like we saw in the previous slide, we have a narrow, fast flowing current that comes through the Yucatan Strait. So here's Mexico, Cuba, Florida. So it comes through, it meanders. So it's set up quite a large meander here. And then it goes through the Straits of Florida and becomes the Gulf Stream. About a week later, this meander that we saw here has gone around and pinched off. Now, the most efficient path for the main current is around Cuba and then out through the Florida Straits. And this area that was the big meander before is now a self-contained eddy with high currents around the outside. This anticyclonic eddy will now propagate towards the west at around 2 to 5 kilometers a day. And so over here, you can see an old eddy that's propagated all the way across the Gulf of Mexico. This is an animation from that same numerical simulation. You'll see a meander in the main current, and then it heads off to be the Gulf Stream. As the animation plays, you'll see this meander pinch off and start to propagate to the west. You saw that while the eddy that pinched off early in the simulation was propagating across the Gulf of Mexico, the loop current was meandering around and it's now pinched off yet another eddy. Loop current eddies in the Gulf of Mexico can be important for a number of reasons. So here's a couple of examples. When a loop current eddy forms in the Gulf of Mexico, it pinches off warm water. So we end up with a warm core eddy. Hurricane Katrina, which hit New Orleans in August 2005, passed over a warm core eddy in the Gulf of Mexico. Hurricanes get their energy from warm surface water, so passing over this warm core eddy strengthens the hurricane. A second example is with the dispersion of pollutants from the 2010 Deepwater Horizon oil spill in the Gulf of Mexico. A major concern after that oil spill was that the oil would get into the current and eventually make its way into the Gulf Stream and be spread throughout the Atlantic. Fortunately for the Atlantic, a loop current eddy trapped a large amount of the oil and prevented it from getting into the Gulf Stream.